Hello everyone, I'm Bhushan, and today we'll talk about how you can deploy ML models over Edge using Qualcomm AI Hub. So the agenda is understanding like why on device, how you can use Qualcomm AI Hub, what does a developer workflow looks like using AI Hub to deploy your models, and we'll also do a hands-on deep dive. We have a Colab notebook to share with you that you can just get started with, and we have like really small demo to show you like Llama 3.2 on device running on an Android platform. So let's get going. As you can see, like these are like some of the use cases that we all of us like use on day-to-day basis, and all of these use cases are powered by on device. For example, if you're capturing a photo or video with your phone, uh, around 25 to 30 machine learning models are running on your device, and like some of these use cases are only possible if you are fully on device, and like there's no cloud involved for running machine learning models. So on device like does seem like is being quite like used right now in our system, but still it's not that easy to use as a developer, and that's something like we're simplifying with the AI Hub. Our goal is to make every product, application, and device more intelligent, and we want to enable that by allowing all developers to integrate AI in their apps on every platform that is possible. So let's understand why on device and what is an incentive to use something use models on device. First is like cost. So let's say if I'm a developer and I have a PyTorch model and I want to run that model on device, or I want to integrate that into an application, it is very easy to use cloud because you have a PyTorch model and you can just use any current system that is any cloud provider that is there to run your model, right? But when you let's say scale your application to a million use cases, at the time cost really starts to hamper because now you have to pay in exponentially cost to cloud provider to host and run your model on cloud. But the all the users that we have out there have like really powerful devices in their hand. It could be compute device, it could be mobile device, it could be IoT device. So if you run a model on device, then all of that cost goes away because you're running for free on a powerful device that user is carrying with them. So that's one of the like very important cost factor that developer has a motivation to run models on device. Second and most important in my view is privacy. When you run a model on device, the user data stays on device, and that way like no data is shared across cloud, so user is like more comfortable running, let's say, using the use cases of a particular app. Third and most important is also performance. Performance also aligns with, for example, accessibility. Let's say if you like hiking and I'm going on a hike and I want my drone to follow me, then if a drone is doing object detection on cloud, it won't work at all because A, it requires like really performant, let's say 30 frames per second speed. And second, it shouldn't require any internet connectivity because you're on a remote location. And let's assume you have a very high bandwidth internet. Still, there is a cost occurred by sending and receiving data from cloud. So if you run a model on device, like fully on device, that does benefit user as well as developer from overall perspective. Let's understand about when you run a model on device, what does it mean? Like what are accelerators that are available for developers? So depending on the use case of your application, we will be using one of these three accelerators, or maybe together as well. For example, if I'm running a game engine, then I want to use GPU resources to render the frames. I would like to use game engine to compute some of the, let's say, ray tracing or something like that, right? And I would like to reserve my GPU resources for that particular use cases. I would use some of the CPU computation for some of the heavy mathematical operations. And having an NPU on device helps me run all the neural processings on NPU. That way, CPU and GPU are free to do what they can do best, right? And as of now, like most of the devices that we ship right now, for example, Snapdragon Gen 3 or Snapdragon 8 Elite that is recently announced by Qualcomm, they have like very powerful NPU being shipped as part of SoC. And leveraging NPU to accelerate your like ML workloads makes sure that you're getting like fully performant AI on device. So in our next talk, we'll We'll touch base on how NPU is helping you get the most performance and how AI Hub is also helping you get most of NPU. So when we started, we looked into what are the challenges in deploying models on device, and most of the developers will start with one of these three frameworks. It could be either Onyx, PyTorch, or TensorFlow. And when developers try to use their models in their use cases, the app might crash. 70 to 80% of the data that we saw, like we looked into like many ML models that are out there, for example, from Hugging Face, and 70 to 80% of the models won't even convert. So we had to build a tool ourselves, like in house, to convert models from Onyx to TensorFlow. And when we saw the conversion, then after conversion, like less of the 20 to 30% of the models were very poor in terms of performance, and some of them were also resulting into incorrect results. So we looked into like how can we simplify this whole process, and we found there are like three key problems that we need to solve. And first of that is getting started. Like let's say if I put my developer hats on, when I do an ML development, my first problem is how do I get right model for my given use case. For example, I'm doing an image segmentation, and then which model shall I use? What model parameters like does work for my use case, and it also aligns with what type of devices you're targeting, because depending on the device, you have to define the model size as well. So there are n number of parameters that are required to define how do you start with a model in the first place. The second key area is, let's say now I have a problem, I have a model that I need to start with, but how does it perform? And when I deploy a model in my use case, I won't be deploying on one particular device. I need an access of a variety of platforms, for example, mobile, IoT, or compute, or XR devices. And even in those use cases, I might have a variety of chips. For example, if I'm deploying on mobile, there is Snapdragon Gen 2, there's a Snapdragon Gen 3, and like the new one. So how do I make sure the model and use case that I am deploying to is performant across the board? And let's say this problem is also solved, but how do I rapidly iterate over this? Let's say if I have a new model upcoming, let's say I deployed a model SAM, and now there's a SAM 2. How do I rapidly reiterate and make sure my users are getting like latest and greatest performance and models as well? So these are like the three key problems that we wanted to solve, and that's how Qualcomm AI Hub was born. Qualcomm AI Hub makes Qualcomm and Snapdragon a default platform for on-device AI by solving and making these three key problems at the center. We'll do a deep dive into each section on how we are solving each particular aspect. Next. So let's look into how model discovery can be solved. And that's where we have a Qualcomm AI Hub models. The Qualcomm AI Hub model has more than 100 pre-optimized models that you can use across mobile, IoT, and compute. And let's say if your use case is not being solved with current set of models, you can always bring your own model, and that's where our AI Hub platform comes into picture, where you can bring your own model, you can compile, you quantize, you can deploy that model right within 5 minutes. And so, and this is the second part of an equation where you have a model or you bring your own model, but how do I reiterate on that model in continuous fashion, and how do I deploy that on device? So this is like a workflow of a developer when using Qualcomm AI Hub. So developer picks up a model, for example, from Qualcomm AI Hub here, or they bring their own model, and then they choose a target platform, for example, mobile, and then they pick up a runtime. For example, I'm targeting QNN runtime, that is Qualcomm runtime, or I'm targeting Onyx runtime or TF-Lite runtime. So depending on the use case, you might have to pick up a different runtime. And once you pick up, let's say, platform and target runtime, then you can quickly test and validate your model with Qualcomm AI Hub platform. And in this platform, you'll be able to compile, profile, and also numerically validate your machine learning model. And once you're happy with your performance of a model, you can just go ahead and deploy the model with some of the sample apps that we have, or you can build your own sample app, your own app as well. As of today, more than 1,100 companies are using AI Hub in their ecosystem. that includes both end-to-end shipping the models in their products as well. Recently in Snapdragon Summit, we also announced our global ecosystem expansion with some service collaborator, AI frameworks, and model makers. I'd like to specifically point out Amazon SageMaker collaboration, where right now you can train your own model with Amazon SageMaker and then deploy using AI Hub. This does align with our bring your own model strategy, where if the model that is present on AI Hub does not serve your use case, you can just fine tune the model with your own data set and then you're ready to deploy. And we also work with some of the really great model makers and made their models available on device on Snapdragon platform. For example, as of today, all the Llama family models you can run on Snapdragon platform. We have Mistral 3 billion, Mistral 7 billion running on device on Snapdragon platform, and Ministral models will be coming really soon. So let's take a pause and let me show you how the Qualcomm AI Hub model looks like, which is part of our first equation on model discovery. So this is a landing page of aihub.qualcomm.com. And as you can see, once you land on a page, we show you the ecosystem partners, which are some really very genuine specific use cases which you can try on. But with the interest of time, I would like to focus on one particular use case right now. Let's say I'm a developer and I go to aihub.qualcomm.com, and with a specific use case in mind, I want to run a segmentation model on device. And I'm focusing more on the mobile use case. So I go to the mobile tab. As you can see, we already have some of the sample apps ready to use. So what does it mean? You can use a model from AI Hub and directly deploy in some of the sample app. Having sample app as a developer, I find it very, very easy because now I can understand how model can be integrated with the app itself. So it gives you a great starting point for anybody starting from scratch. And when I scroll down, I see all the models listed here for mobile, which is 131 as of now. But I'm more interested in, let's say, computer vision use case. So I click on computer vision, then I go on semantic segmentation, like that. That's what I'm looking into. Um, and as you can see, these many models are available on AI Hub to use right away. For the demo purpose of this talk, I have prepared a demo with FFnet. So let me just open it up and show you what all data is available to look into. So as you can see, here we list all the platforms that the model is optimized for you to use. So I will be using, let's say, Snapdragon 8 Gen 3 for this talk. And once I click on Snapdragon Gen 3, I also get an option to pick up a runtime. For this talk, I will pick up a TF Lite because TF Lite gives you general access, right? So let's say if I have a TF Lite model, I can deploy it on any Android device. So I will just go with the TF Lite model. And here the Qualcomm AI Hub shows the metrics for a given model. For example, it takes around 12 milliseconds to run this model for one inference job. And this model has around 92 layers, and all of them are NPU resident. So if I'm interested, I can also look into more metrics here. It shows a detailed overview about where and what is happening for this model. For example, all the layers of this model are NPU resident, which is a great thing. That means we have performance model here, and I can just download a model, and now it's ready to use. As you can see, I have just downloaded this model. But let's say if you're interested for an advanced use case, we also have a GitHub repo where you can just go from the website by clicking on model repository. And now you have access to the full source code of this model. So let's say if you need to modify the model, you can just go into model.py, modify the network, and export it to fit in your use cases. So I think we'll pause for now and we'll go back to the slide. But before we go there, I would like to point out we also have some of the ecosystem community pages here to get you started, where you can jump and learn more about AI Hub. We will talk more about this in our talk. Uh, just to take a break here. So Megan is also here from Qualcomm AI Hub. So if you have any questions, please shoot them in the chat. Megan should be able to answer those. And at the end of the talk, we'll we'll discuss the questions as a group as well. So let's look into this AI Hub developer journey in more detail now, like as you have seen the website. So the website solves the problem which is mentioned here, where you pick a model from AI Hub. And let's say you have your own model as well. That could be a PyTorch model or Onyx model. Then developer picks up a device, which in this case, let's say I pick up a Snapdragon Gen 3, which is let's say Samsung Galaxy S24. Then I pick up a runtime, which in this case I picked up a TF Lite runtime, but we also have Qualcomm as well as Onyx runtime as an option to use. So once a device and runtime has been picked, the developer just submits a job to Qualcomm AI Hub using Python API. I will go in the APIs right after the slide. So once you submit a job to Qualcomm AI Hub, within 5 minutes, you should be able to compile your model, optimize the model, and then Qualcomm AI Hub, the cloud service, will, after compiling and optimizing your model, procures a physical device from a device farm and then prepares that device to run your model on device. And once the model is run on device, it returns all the profiling and validation information back to the user. So that way user knows exactly how long it takes to run your model on device and how numerically accurate your model will be when you run your model on device. Because running a model in Float 32 in PyTorch land might be different than running a model on your device. And once the cloud service has finished, the model is returned back to the user. And now the developer can use this model and integrate that into their own applications. And to get you started, we have sample apps that I just showed you. So let's look into some of the APIs that we have to get you started. We also have some of the links mentioned in the slide that you can go and read into. But don't worry, all of these links are already present in aihub.qualcomm.com. So that will be a good unique point for you to learn more about this. But I just wanted to go more in depth about what is happening for both all the compilation and profiling job at AI Hub internally. So when you submit a compile and optimized job in AI Hub, a PyTorch or Onyx model is converted into an optimized model format. And it could be a Qualcomm binary, it could be Qualcomm model library, or it could be a TF-Lite model, or it could be an Onyx model. And the API looks something like this, like where you just submit path to a traced PyTorch model. You pick up a device that we just saw, and then you set some options. For example, here we set an option to run a model on Qualcomm model library format. Once you have an optimized model, you can optionally quantize it as well. So this is one of the latest feature that we have, like we recently launched. So once we have that, so in some of the cases, you might want to quantize model to, let's say, for example, if you're targeting IoT use cases, and that's where quantizing model comes like super handy. The content job does require an Onyx model. So one uses compilation job to compile a model, and then you can submit the same model to quantize on AI Hub. The quantization job will take up a Onyx model and will return a quantized Onyx model. So just to give an idea, right? So for example, if you submit a Float 32 model, then output of this quantized model will be, let's say, almost one-fourth of the original model size if you quantize with intent data. That really helps in some like running models on edge, on for example IoT, and as well as like speed up LLMs on device. The second job is second use case is profiling your model. For example, now developer has compiled their model. The model can run on device, but there is no data on how long it takes to run a model on device. And this is a very important criteria when you're running a model. For example, let's say if you have a video use case, you want to make sure your model is performant. You want to make sure your model is not consuming a very, very high memory, peak memory that could potentially crash your application. So that's where you can use this submit profile job, which let's say if you already run a compilation job, you can directly get a handle to your target model. So you don't have to download model locally on your host machine at all. And then you pick up a device of your interest, and then you submit a profilation job. The profile job will return the inference metric, like how long it takes, what is a peak memory usage in the app, and also the compute unit distribution. So the compute unit distribution comes super handy. For example, let's say let me go back to a game engine use case. I want to make sure my GPU resources are entirely free for rendering. So in that use case, I want to make sure all the AI models that I ship are not using any GPU resources. So if you let's say if you have something similar use case, then profile job is really helpful, because now you can use profile job to understand that my GPU resources are free indeed, and my model is maybe the CPU or NPU resident. And so now I have compiled model, I have quantized the model, I have also profiled it. I'm happy. But what if your model does not produce a correct result? Then it really doesn't matter, right? And that's where we have something called inference job, which an inference job accepts a data that this data is run on device, and then the output data is returned back to the user. So what inference job allows you is to build an ecosystem around your use cases to create more and more metrics. For example, I just need to make sure my PSNR is good, so I can use inference job for my compiled job from AI Hub, and then I can do comparison of my target flow 32 model with optimized model from AI Hub. That way, I can validate that when I run a model on device, it does produce correct results and it doesn't produce any garbage values. So we also have a very, very highly active developer community. If you haven't part of this community, I would highly encourage to join you. Highly encourage you to join this community. We answer questions like really fast on this community, and we post all the updates here. So if you want to learn more about Qualcomm AI Hub and running models on device, please join this one. We also have like really good resources to get you started. We explain in depth like how you can run models on device, how you can compile, how you can convert the model. Um, so please check this out. Yeah. Now let's try Qualcomm AI Hub together. If you have setup ready right now, you can just go to this link tinyurl.com AI Hub hyphen segment, and this will take you to this particular collab notebook. I think my just disconnected, so I will just rerun this. This notebook shows you how you can use AI Hub in your workflow and does go in depth for each and every job. For example, compile, profile. So we'll go in each job. To get you started, so first step is to install QAI Hub and QAI Hub models. So the QAI Hub is a Python client for Qualcomm AI Hub platform, and QAI Hub model is a Python package that has all the models ready, pre-optimized models ready to use. First step is to just install this, and until it installs, we'll just walk through all other source codes. The second stage is basically how do you get a model. And for example, here for this demo, we are using Qualcomm Hub model, FFnet model that we just saw on the Qualcomm Hub website as well. So the one option is to download a model from website directly, or other option is you can also get a model from our Python client. So here you take a model from Qualcomm AI Hub models. You load the model here. You load the input spec, and then you JIT trace a model to get started. So once you have source model ready to use, now the next step is to set up your Qualcomm AI Hub credentials. So for that, you just go to app.aihub.qualcomm.com. You go to your setting, and then you just copy paste your API token from here. Don't worry, I'll be changing my API token. And then you set up Qualcomm AI Hub configure API token, and then you are ready to go. Yep, now you're all set to run models on device using Qualcomm AI Hub. So just to check how many devices I have access to, you can quickly check that by running QAI Hub list devices. It shows you all the devices, OS, vendor, and the chipset like in detail about what all devices you can run the model on device. For example, you can see we have we have some of the Android devices, some of the IoT devices as well here, and we also have some of the compute devices. For example, Accelerate should be here. For example, yeah. So let's get access to a device handle. So by doing this, we get a device handle called Samsung Galaxy S24 that we can use for rest of our talk. And I also set runtime, for example, TF Lite. So let me just quickly run this. In the interest of time, I already ran this in the morning. So once you run submit compile job, this particular source model will be submitted on cloud. Let's see how it looks like. Uh, this is a AI Hub platform where now compilation job has been submitted and it will run in background. So let's look into the previously ran compile job here. As you can see, once the compile job finished, you get access to some of the intermediate access. You also see compilation log that you can go over. If something goes off, you can always look into the compilation log to get more detail. And we can also visualize the model. So let's go back to the Colab notebook. Now, so once you run a compilation job, and let's see if it finishes, then you can also get a target model and submit a profilation job. So when you submit a profile job, you get a target model that you previously received from compilation job, and you run on a selected device. Let's look into how a previously profile job looks like. And as you can see, when you run FFnet on device on Galaxy S24, it takes around 20 milliseconds to run. The 94 ops are running on NPU. The best part of your profile job is to see the visualization where each op is color coded on what NPU it is running into. For example, since this model is fully NPU resident, you don't see any variation as such. But NPU, CPU, and GPU will be color coded. I find this very useful. When we first started, we didn't have like much of NPU residency, so this visualization job really helped me understand and find new performance optimizations that we can do either in PyTorch or in your graph framework to improve overall NPU residency. And this also shows what is the first load time, what is the subsequent load time, and what is the inference load time. This is like very useful in general when you are considering like end-to-end deployment use cases. So once you have a profile job as well, now you know you're happy with the performance of the model on device. Let's time to check how model performs in terms of inference. So you just submit an inference job. We get a target model from compilation job. You provide a sample, which is, let's say, this like random data here. I have written this like small PSNR metric where we just compare both the Float32 torch model with the output of on-device model. So inference job is currently waiting for completion. So we'll quickly run this and we'll wait for it to finish. Until we wait, we'll go back to the slides and see if you have any questions. Okay. Let's see. Okay. We also have some of the good demos for you to try today. So if you go to tinyurl.com LLM Genie, we have a tutorial written to help you run all LLMs on device on Snapdragon platform. So this shall take you to AI Hub apps, tutorials, LLM on Genie. We walk you through each and every step where you can, how you can export large language models to run on device, and how you can actually run it using compute app that we have, and some of the command line tools that we have that you can use to run this on device. I do have a sneak preview for you on what's coming on Qualcomm AI Hub. So we are also working on an Android app to run these models on Android devices. That will be soon part of AI Hub models, AI Hub apps. So just export the models with AI Hub, and then you can run it on your Android devices. So I will quickly show this demo.
Bhushan, there's two questions that have come in that could be good to answer live, and then we can go to the demo if you don't mind.
Yeah, yeah.
So one question was, what could be the reason for a model layer to not be compatible with the NPU? What's the difference?
Okay, that's a good question. There are it depends on what NPU you are actually targeting into. So NPUs are it's a specialized accelerator, and as part of a specialized accelerator, it might have some it might be performant on some use cases, and it might not be performant on some other use cases. So most common constraint that I have seen is the amount of data. For example, let's say if you're working on like really large tensors, sometimes it might not fit into an NPU memory limit, and that could be reason that it might fall back to CPU or GPU. So like that's one of the most common reason I've seen. And others is it just maybe a software stack or NPU itself doesn't support those operations. Like usually what happens is like we have, let's say, compiler stack on top of an NPU that is responsible to make sure your model is your op is performant for your use case. So let's say if support is not present in your compiler stack, to maybe unfold your op into decouple that op into some other operations to make it run, then it might just fall back like that. That could be the reason. Yeah. And,
Awesome. And then one other question for now. Does the compilation take place on a real device, or is there cross-compiling method taking place?
no, the compilation. So the compilation is not happening on device because compilation can happen offline. So, for example, if you're targeting on Qualcomm QNN, let's say Qualcomm runtime, you can actually do that on Linux box as well. So wherever you have Qualcomm SDK is available, you can just cross compile it on Qualcomm devices. If you're targeting TF Lite, then you can compile it anywhere. You can compile it on Mac, you can compile it on Windows, you can also compile it on Linux. So as long as you have a target asset that runtime can understand, you're good to go. Okay, cool. If you have any follow up, please let me know. Meanwhile, I will just jump to chat app. So we have this chat app that should be part of AI Hub app soon, and we have got like Llama 3.23 billion here. So uh, I don't know what to ask, but yeah, I'll just ask what is gravity. Let me just sign it up. And yeah, so as you can see, like there is like no internet connectivity. It's all there seems to be internet connectivity, but yeah, it's running all on device. Uh, and so this particular model was exported using AI Hub models. For example, if you want to export this model, you can quickly follow this guide LLM on Genie. You can follow the instructions for Llama 3.23 billion, and you should be able to run this model. As of today, you can run this on compute, and for compute we have a CLI app. Let me just quickly show you that. Yeah, so right now like we have two ways to run these models. One is Genie 2 runner CLI command line, which you can run on Android as well as any compute that has Snapdragon X Elite, or you can also use our CLI based Windows chat app. It's just part of our AI Hub apps, and it looks something like this. It's a interactive chatbot CLI based, and what I just showed you is something coming up real soon on our platform. Okay, I think let me go back to the slides. I think that's all for us. So I think we'll just stop at here. So you have pointers to capture for our AI Hub resources and Slack community.
All right.
Awesome. And if
Go
anyone has
ahead.
questions, I've been answering them in the chat as we go, but I can mention one or two more. Sorry, Jimmy, to cut you off.
No worries. Yeah. So once again, the follow-up is that we'll gather up all the resource links and put them into executive summary in the follow-up email on the summary blog post. Plus, we're going to make the playbacks available to everyone. So you'll be able to catch all the demos one more time. If you have any burning questions, we highly recommend that you ask those in the Q&A now before we lose our final speakers here. So we'll go ahead and leave the webinar open for a couple more minutes if there are any burning questions that people want to answer. Otherwise, I want to thank everybody for taking time out of their day and bearing with us here with this particular meetup. And we hope to see you at another one soon. I'll post some of the links to the other webinars as well. So Qualcomm folks, if you want to wrap up your questions here, that would be awesome.
Yeah. I think the first question is that I will take is from Julia. Do you have any recommendations for using models in extended reality as it integrates the TF-Lite and Onyx format models? Yeah, that's a good question. So let's say if you're targeting Qualcomm platform, Qualcomm does have a lot of devices in XR. You can use Qualcomm context binary. So when you use Qualcomm AI Hub, you can just pass hyphen option target runtime as QNN context binary, and that will give you like asset that you can directly deploy on XR devices. Yep. I hope that answers your question. If it does not, please put up a question again. I think we can do a follow-up. Second is from Yuvraj. From the efficient net paper, they recommend using group convolution instead of using depth-wise convolution. Is there a sort of analysis done by QAI? We haven't done any analysis per se for this particular comparison, but in general, like group convolutions are like known to like run faster because you're reducing the compute in general. So using group convolutions, I would personally recommend, but it really depends on your use case, right? So let's say if that works really well for your given application or your given use case, then please feel free to go with that, because it does require some training and things like that. So it's up to your particular use case on how it performs for your data. Yuvraj also have a follow-up that they recommend grouped con for NPU. Um, so it really it depends. Like we do also have some of the graph transformations. So depending on like whether you have a depth-wise convolution or group convolution, typically NPU's compiler will do a graph transformation to convert into format that best fits for NPU. So ideally speaking, you shouldn't be worrying about that. Like you write the way that is best for training, and let the compiler do the magic, and compiler will basically do the best that is for the inference.